So, looking at this lab, it's actually pretty easy. We kind of, in class, we actually discussed some of this stuff. But we're actually given all the addresses, which is the difficult part. We have our management interface for our Class A switch or Class B switch. We're given an IP address. Subnet mask's all provided for us, which is a /24. We are going to throw 2 computers on there. We're going to throw a couple switches, connect them together. Since they're dissimilar devices, we can use straight through cables. We have configure PC hosts. That's easy peasy. Adding a console cable connection, and then we're going to go through. Yeah, sounds good. Let's get this started. Throw this over here. Twitch TV, let's open that back up. Apparently I'm streaming Splatoon, interesting. Okay, so let's see what we got here. Let me just drag that over like that. Perfect. So we need to add 2 PCs. We got our end devices, PC1, PC2. We need to go ahead and add our 2 switches. So we go down here to network devices, switches, 2960s, bang, bang, check those 2 there. Go to our connections, grab our straight throughs so we can connect it. Does it say specifically which port it wants us to connect? Connect the switch, connect the switch. Fast Ethernet. It does not specify, so we can connect any port then it looks like. So let's go ahead and connect our fast Ethernet to our fast Ethernet. Our fast Ethernet to our fast Ethernet. And then it says it wants us to connect our 2 switches together using fast Ethernet as well. So that means we'll just grab the highest port. And ports usually are more of a preference than numbers, but usually you want to keep the uplinks together. And the computer is in a similar way. So we got that going for us. That's cool. Let's go here. It wants us to rename this to student PC. So we got student. Two. Cool. And let's rename this one to student 1. Sounds good. And then we're going to have to make sure we configure our IP addresses on both these machines. Interestingly enough, the document says to switch and do the same thing for student 1 and student 2. However, the device tables are actually the same, so we're going to go off the assumption that the first address in the list is the one and the other one's the other. So what we're going to do is we got our IPv4 address interface, smack that button there. We're going to configure 192.168.1.10. It's going to default to a /24 as our subnet mask. If we go back to that global area, you'll see the default gateway and the DNS server aren't configured. We can just leave those empty for now. I don't believe they actually get set because you really only need those to get outside of the network. Since we're not getting outside of the network, it doesn't really matter. Let's go to PC2, interface, fast Ethernet. We can configure our IPv4 address 192.168.1.11. Same thing, defaults to a /24. Same thing as before. Settings, that stuff is there as well. And it also wants us to set up a crossover cable between our machines. RS-232 to the console cable connection there. RS-232 to the console cable connection there. And that's going to allow us to configure it. There we go. Now we got our desktops complete, which is golden, so we can work on our terminal configurations. So let's go to student PC1. We can go to the desktop. We can open up a terminal. And we can open that up. And our switches have been powering on while we've been doing this, so that's kind of why we get all these extra little bits here. We plugged in some cables, so we get our lines flapping up and down. So we're going to enter in our privilege escalation mode, so enable. You can just type in EN or enable. And then we're going to configuration terminal, so we can do config T, bada bing, bada boom. We are on switch 0, which is our first switch, so we're going to switch the host name to class-A. Bang, that's good now. We can open up this one, and we can do the same thing. So we go to terminal configuration, we got all that fun stuff. We're going to go to privilege escalation mode, or privilege execution mode. We got our switch, configuration T, so global config. And then we can do our host name as well, class B. Cool. And what you'll probably notice is, yes, the host name has changed. However, the switch still stays the same. If you want to change that, you actually have to go into the config here and class-B. And funny enough, you can actually change all of the settings from this little GUI area, but it's better to just know how to do it from the command line, because in the real world you don't get this fancy ability to click on here. But when you click on it, you can actually see what commands it's executing. So then it makes it a little bit have a helpful hint. Switch 0 here, class-A, just so we got that on the know-how. So what we're doing next is we're going to be setting a password to get into our enable mode, and we're going to set our console password as well. So let's go ahead and configure those for both. So enable secret class, and we can go into our line console, which is what we're currently in right now, line console 0, password Cisco, login that we want to prompt for the password, and then we exit out. Then we have our line VTY 015, basically just representing the first line, or any line. So if you're using Telnet or SSH, 0 is going to be the first connection in, all the way up to 15. So if you look at programming, if you have an array, 0 through 15 is actually a max of 16 connections. If you configured it like 0.4, then it would just give you, 5 connections. But line VTY 015, password Cisco, login to prompt, exit, and then we're going to configure that super secret service password encryption. So if we do our show, so let's exit back, show, if we do our show of our running config, we can actually see that we have our super secret type 5 encrypted password. Nothing really special. But let's go to our other switch. So on here, I'm actually in interface mode, so I'm going to bounce out one, and we're going to go and configure our secret and our stuff. So enable secret class line con 0 or line console 0, password Cisco, and then we're going to tell it that we want a prompt. We're going to exit out. Line VTY 015, same thing as before. We're basically configuring 16 connections. It's the max that's available for remote access. And when they connect in, they're going to be having to use the password Cisco. And we're going to force it to ask, exit. And same thing as before, we're going to do our service password encryption. That way we encrypt the passwords so they're not so easy to understand. So right now we're on our switch B. So what we're going to be doing is we're going to be configuring the Vlan interface. This will be our management interface, which is going to allow us to actually connect to it over like an SSH or a Telnet session. So we can go into our interface, Vlan 1. Okay, and VLAN 1, what's our IP address that we need to be using? We're on switch B, so our IP address is 192.168.1.2. We need to supply our subnet mask, which is a /24. Always be careful with the subnet mask. A lot of people make those mistakes. And then we're going to bring the interface online by using the command no shutdown. Bam. So our line protocol is up and our interface is up. And sort of as we were showing class, if we exit back out to our enable mode, we can do our show IP int brief. And we can see we have all the way at the bottom, we have our VLAN 1, and it is currently up and up. So line protocol and the physical is up. As well as we also have our fast Ethernet 01 is up because that switch is has a cable plugged into it on that one, and our number 24 is up. So let's go do the same thing with switch A. Configuration terminal, and then from inside of here we can do our interface. So interface VLAN 1. IP address 192.168.1.1, same sort of subnet mask bit. And then we're going to need to do our no shutdown to bring the interface online. Line protocol and physical state are now up. In a real switch it takes a few seconds sometimes, but that's pretty quick. And then what we are going to do is we're going to configure our message of the day. Our message of the day is kind of actually interesting anyways. Only for the fact that the instructions tell you just to configure it on the line, but you need to decide where you want this to physically be. So if it's going to be on our line console or on our line VTY, we'll need to do that. I'm kind of really out of order, but anyways, go back here. We can do our line con 0, and then from inside of here we can do our banner MOTD hashtag, and then we enter in our thing. Unauthorized access is strictly prohibited and prosecuted. Prosecuted to the full extent of the law. You might ask yourself really why you need that. there was actually a case way back in the day where someone's message of the day said welcome. It didn't say you were unauthorized. And the people actually got off the hook because it didn't tell them that they weren't supposed to be in there and what the rules were, which is oftentimes why you see in companies when you log into the computers, they give you that little prompt that pops up and tells you what you're expected, what you are and aren't allowed to do, and why, etc. Same thing as well here. We're going to go into our line console. So we go into line con 0. And then inside of line con 0, we're going to do the same message of the day, but let me see if I can just copy and paste it, because I hate typing stuff like that. Copy, banner, MOTD, hashtag, paste. Oh, perfect. And there we go. And if you wish to check your work as well, we can do our show run. Oh, gotta go back one. Show run. Yeah, we got our message of the day, and that's the reason why it kicked me back, was because it had this little control character at the end of it that I got in my thing. But yeah, so we got our message of the day banner set, so that's fine there, I guess. Let's go to the other one. Show run, right, exit, show run. Cool, we got our message of the day banner set. Typically, when you set your passwords as well, you never want to set the same password for your line VTYs in your console as you do for your enable password, because of the fact of the different types. The type 7 is pretty easy to break anyways. So we just need to save our configs, copy, run, start. Go to the other one, copy, run, start. All done there. We got our running configs, which you can show. I've already done that a few times. Yeah, we should be able to ping now. So if we go to our machine here, we go to desktop, let's close the terminal. Open up the command prompt. We go to ping 192.168.1.1. Is it going to work? Am I broken? Something is working. Perfect. Yeah, so the first one just timed out because it takes time for it to basically build up the stuff. Did I connect that one wrong? I did. Interesting. And as you can see there anyways, it should actually be a crossover as per the rules, but you probably noticed that it worked anyways, and the reason being is because I think most electronics in the current world utilize auto-sensing ports. So the ports themselves will actually correct that. And if you wanted to delete and do what I just did, you just basically click off of whatever you're doing, hit the delete button, and then click on the X on the link. So it'll take a second for that link to come back online. And we can actually see, if we open up our terminal again, we can see it basically, it came back online in that process. So it went down when I yanked the cable, the physical interface was down, and then the line protocol obviously went with it, and then it went back up and up. So as long as you're up and up, that's all that matters. Then we do our ping 192.168.1.2, which should hopefully work. It will probably fail the first time, and then it will go through. Cool. Now let's go to the other computer and do the same thing. Ping 192.168.1.1. Same thing, it's going to fail the first time as it builds its ARP cache. You use the up arrow just to switch it to our .2. So that ends up working there. Basically, that's the address of our management from both switch A and switch B. Switch A, switch B. Is there anything else? We got our pings. Those are complete. From the switch, ping PCA. Yeah, perfect. So it wants us to go onto these switches, so we can close this back out, and we can go to our terminal, open that back up, and then from here we can run our ping 192.168.1.10. Ping was successful, and then we can do our ping again 192.168.1.1. Perfecto, and then we can go to our other one. PC, close this, go to our terminal. Inside of our terminal, we can go ahead and do our ping 192.168.1.10. That works perfectly fine. 192.1611. That also works perfectly fine. And that's actually the end of this lab. But one cool little feature, if you didn't already know, and you want to see how this kind of all plays out, you can actually switch from real-time to simulation. And if you don't want to go to the command line and type in packets, you can actually go up here and you can click on Add a Simple PDU, and you can press there and there. And then basically what happens is you can go ahead and hit the play button. And what's going to happen is you can actually see it in real time. So I'm sending off an ICMP from our one computer to the other, and then what ends up happening is it sends off a ARP request to try to locate where this PC is from each device. We see the package going around. It's kind of like what it's doing in the real world. And the package comes back successful. It's very excited, and it's going to do that a second time now. Now that it knows where it is, via the ARP bit, it's now going to send the actual ICMP packet out. And after this is done, you can actually click on the simulation panel and see the frame. Ugh, I don't want to wait. Can I just go faster? Anyways, yeah, you can click on the actual frame itself, and it will actually show you the OSI model. So you see what port it comes out on, where it's being destinated to. So we look at the layer 2 header.